Hello everyone and welcome back to my channel. And I've received a few emails asking about programming this part on the lathe, and also I've got an email and a comment asking if this part can be programmed using 2D toolpaths or 3D toolpaths. So we will talk about 2D gallery today and axis substitution. Okay, so in this case we will use pocket and contour, and we will machine whole channel using those toolpaths, and we will replace the y-axis motion with the rotary axis. So I prepared a few operations already for the lathe, and this will be used as example. This is the stock model from the turn-in. So we have our stock prepared for our machining. And of course we have to start with selecting our machine, and for our tutorial I selected lathe default, so everyone has that in their Mastercam and can follow our step easily. So first let's switch off material rendering, because it'll be easier to see the toolpaths and the result without rendering. And we will start with machining this side of the channel. So for our first example, we are going to machine all these using pocket, 2D pocket. So first navigate to 2D gallery and select pocket. And I'm going to select a face, and as my machining geometry, or as a chain, I'm going to select the floor here of this channel. Okay, so I've got some extra passes, so I'm going to remove that, and instead of that I'm going to use a loop. Okay, I'm going to rotate this to be on the edge and slowly approach it until I highlight the outside shape. Okay, so this is my chain. That's fine. And of course, as you see, the chain selected doesn't include the radius, okay? But every radius on this channel is the same, so the all radii is 2 mm. Okay, and as my tool, I'm going to use 6mm bull end mill with 2mm rad. Let's set some feeds and speeds. Oh, no zero, we have to use something, so 1000, let's say 1000. And then spindle, let's put it as 4,500. Now let's quickly set our cut parameters. And at the moment, our toolpath or our chain is set to this edge of the floor, so it doesn't include this radius around, this fillet around. Okay, and when you have the positive, so plus value here, Mastercam will leave a stock. And to cut bigger than your chain, you need to put minus value, and in this way it will overcut the pocket. So if it's a plus, I will leave stock, and because our chain is on that edge, I want to do minus, so it will offset the value of the fillet. Because fillet is 2mm and we have stock to leave on -2, it will go bigger. Standard cutting method. And now in the roughing parameters, we have various cutting methods that you can use, and I recommend always to try to play with this a little bit, check different things. I'm going to use a zigzag, and my step over percentage, I'm going to use 40% or even 25% of tool's diameter. And depth cut, I'm gonna go the full depth, but I'm going to finish 0.2 on the floor. So let me change that to 0.2. Yeah, so this is one roughing cut and then one finishing cut. In the finishing, so this is how we're going to finish our walls. I'm going to do 0.2 mm, and with the compensation on the control. You can also set here a different feed and speed for your finishing cut, And let's move to lead in, lead out. And I'm going to use 60% of tool's diameter for the length and the arc entry. And my line to get into compensation is going to be perpendicular to the radius, to the arc. Okay, if you want, you can use different method and just play with this. I'm going to use both 60% and for entry and for exit. So let's now move to linking parameters, okay? And here, okay, it would be easier if I start with, we come back to here, we'll start with axis control. So because it's a lathe, we need to set our axis combination, and we are going to use upper turret, and we are going to use also left spindle, main spindle. So part will be clamped in the main spindle. So this is left upper, and rotary axis control. This is where you activate your axis substitution. Okay, so let's first, Mastercam need to know what diameter we are machining, where is our chain actually. Okay, so I'm going to right click on this, and I'm going to select diameter of an arc, and then I'm going to select this face that I use as my chain. Okay, so the chain goes on that diameter. Click on that. This is our rotary diameter, and in our example I have to use option unroll, and it is because our chain is located on the 3D model on the diameter, on the rotary diameter that we actually selected. And Mastercam, for some calculation purpose, needs to unroll it to make it flat, and then when it's rolling it back into diameter, it replaces the motion y-axis with the rotary axis. And again, you have to tick unroll if you select your chain like me on this diameter, around the diameter. You don't use it only when you throw 2D pocket and roll this pocket onto the diameter. And here, as I mentioned, this is the diameter where your chain is located. Let's move to linking parameters, and now we're going to use absolute. And basically our depth is not on that point. It's actually because we selected the rotary diameter is located on that face here, on that rotary face. So our absolute position is basically 0 because I want to have my depth on the chain that I selected. Now we can accept all the settings, and I want to see how this toolpath looks like. Select OK. So now our passes, as you see, they are across the channel. And because I'm using a flat bottom tool, bull nose and mill, I want to machine this going along the channel. Okay. So how we can do it is very simple. And you do it as in standard 2D pocket. And if we leave it as it is at the moment, our passes will generate a lot of flat passes on this diameter, and I want it round. So let's go to roughing, and we can change the roughing angle. And I'm going to set it to 90 degrees. And in this way, we will rotate the whole toolpath, all the passes 90 degrees. And in the result, we will have passes along this channel. Okay. Yeah, this is more like what I was looking for. So let's quickly jump to verify and see if it's not causing any trouble. And I know that we will have some unmachined areas on some walls. Okay, no collisions, and let's quickly compare it. And of course we will have some unmachined areas on those side walls here. Okay, so this one is not too bad. Okay, but we have to machine the top, and on this one, even if I then orientate the part this way, I can use 3D milling to finish the sides of those walls here. Okay, however, the floor and the walls are finished. Okay, that's easy on this one. But let's take a look on the other toolpath, on the other channel, to the second part of the channel. Okay, and we have a slight problem because of this feature here. Okay, this wall is vertical, so if we try to use the axis substitution to go through the channel, the tool will be pointing to the center, and we will end up with cutting the top edge of this wall. Okay, but let's have a look quickly and let's see how this is going to work. So first I'm going to quickly copy this. Okay, so this is the same toolpath at the moment. I'm going to change the geometry, rechain this all, and I'm going to use this. Okay, so now let's preview it and let's run it. We don't need to do anything else. Okay, so let's verify this. And as you see in the simulation here, with our 2D pocket and axis substitution, the tool is on the vertical orientation and it is pointing to the center of the rotation, okay, to the center of the part. Okay, so we have our second part of the channel machined, but let's have a closer look into this. And you see we have some not fully machined area of this open pocket, and I don't really want to leave it like this, because when I start finishing it, my cutter will hit the thicker stock of material. And also, as you see here, the top edges or the top parts of the wall are over machined. And if we look into the colors of this over machined, it tells us that this over machined is roughly about -0.1. Okay, we have a slight red, so it is just over 0.1. Okay, over machined. So how we can fix it? And the solution is quite easy. What we're going to do is leave a bit more stock. So we're going to leave, let's say, 0.15. Okay, so in this case, we will have the 2mm would be right to the wall, but 1.85 will leave 0.15 on the walls. Okay, so let's try it. Now let's quickly go back to verify. Now I'm going to fast forward this to see the result, and I'm going to hit compare button to compare it to the 3D model. And I want to see stock left on the walls. And yes, so everywhere is left stock, and even when we are cutting this top corner, we are still having stock. Now we have two simple things to do. First, we're going to take care of this front material, and now we have even thin wall because we left stock everywhere on walls, and then we are going to finish the walls. So how we can fix it? Let's go to geometry. I'm going to rechain that again, and this time I'm going to use a partial loop, and I'm going to select this chain starting here, but instead of going around up to this point again, I'm going to finish here. And in this way we have all that closed, only this side is opened. Okay, this is a warning that all chains must be closed, but we are going to use slightly different strategy. So ignore that, we go to parameters, and now we're going to change the strategy to open. And then you can tell Mastercam how much you want to overlap. Okay, so I'm going to use a open pocket cutting method, and let's have a look how this is going to look like. Okay, let's go this way, and Mastercam will close this, adding this value to this side here. And this is what I want to use. Okay, make sure, because the pattern is going the wrong, not the way we want. And in the roughing, I'm going to change that to 90. And let's simulate this quickly, just quickly. Okay. And look at this. Beautiful. Okay. So we don't have this material left here on the front. It's going to be easier to machine. Okay. And also we don't have any more collision here. So now let's quickly set up our contour operation. So from 2D gallery, I'm going to select contour. And basically I want to contour part from here to here. Okay. Tool. It's just a fillet we're trying to finish plus above the wall. I'm going to use 4 mil, ball end mill, cut in as control, 2D, and here because I selected the outside shape of the floor as my chain, I have to add this radius on the sides to machine from wall to wall. In this case I have to add negative minus to the size of the fillet. Okay, so we'll be overcutting 2 mil to get to wall. No depth cuts, no multi-passes. Linking, of course, is on 0, and it is because we're going to use again axis substitution with the diameter, right click, diameter of an arc here. Lead in, lead out. 55% or 60 maybe. 60, but I'm going to use perpendicular. In this way our tool compensates to this radius, and then using the radius lead into the cut. And I'm going to copy that to the right hand side. Let's see the toolpath. Oh, and the gouge check doesn't work with the compensation on the control. So let's switch off the gouge check. Yeah, that looks good. Let's see on the verify. Click OK, and let's simulate this. These two operations. So we still have this not machined, unmachined, okay? These two walls. But those should be machined. And yes. So now, how can we machine those walls here? So as you see, they are parallel to the axis, okay? So we do not have to create a plane. We can use one of the existing planes. And what I want to do only is measure something. And I'm going to quickly measure the distance between the wall and the edge of the fillet. And we know that the fillet is 2 mil, so why is 2.16? I'm going to use this edge as my chain for my contour operation. And as you see, 2.16 is because the fillet blends into the diameter, okay? It doesn't blend into the horizontal wall or vertical wall, it's just blending into the radius. That's why it's slightly bigger than 2.16. The radius is still 2 mil, but it curves up. Now, before selecting the operation, I'm going to pre-select a tool plane. G-view, and I'm going to use back, okay? So now, in this way, our walls are vertical, okay? That's fine. I'm going to set milling, contour operation, and I'm going to use single line, and with my compensation to the left, I want to go this direction and then this direction here. Okay, as a tool, 4 mil. I'm going to ignore that, it's just to show you guys. So here we set minus 2.16. Lead in, lead out. I'm going to leave everything here as default just now. And in linking, Now, because we are using just a standard 2D contour, my linking, I want to be on incremental, and my depth is incrementally 0 from the chain that I selected. So this is my Z0. So I'm going to use an incremental, top of stock, I'm going to use incremental, fit plane, all in incrementals, okay? My lead in, lead out is okay. My planes are okay. This plane is back. Yeah. Because I can see the feature from this plane. And axis control, I'm not going to use a axis substitution, so I need to use no rotation. Okay, that's fine. So let's generate the toolpath and let's have a look if we are cutting that in the right position. 2.16. Yeah. And okay. Let's jump quickly to the verify. One moment. Let's close that. I want to simulate actually those 3 operations. Okay. And we're going to use fast forward just to see the result. Ignore that, we didn't set our feeds and speeds. Let's use 50 microns. Yes, the wall is cut. The blend is here, okay, it looks fine. So this is what we were looking for. Great. Now let's quickly simulate, fast forward this actually, and I've got my compare set to 0.05, which is 50 microns, and let's go with that. Let's finish and contour first, and then we have our 2 contours here. Okay, we could maybe extend this toolpath a little bit. Yeah, probably. Doesn't really matter, but let's have a look at the result, and we should have all green. Yes, nice. Okay, cool, all blended nicely. And if I program this part, that is also 2D pocket. The small pocket is also 2D pocket, so it is all easy to machine. Okay, if you want to have all these toolpaths as a backup, put it maybe on the milling machine, on the 4th axis you want to use in 4th axis. Let's quickly set it up. I'll show. That's simple. You don't have to change anything. It's basically the same method. Okay. The only one difference when you copy that from lathe is, I'll show you. Let's select our machine. Milling. I'm going to use default machine, and here I'm going to copy all those milling toolpaths. Copy after. Yes, I want to copy that to group, and I want to use so maybe you want to change the planes because D plus D plus Z. So you highlight all of them, right click, edit selected operation, edit common parameters. Then you can select what you want to change here on all those operations. I want to change planes, and I want to use top, and yeah, there we go, rechain, and this is our new plane top. Okay, so that's easy. There are some bits and pieces that we have to change. Okay, I shouldn't have changed this. Okay, this one is still, oh no, sorry, that should be here. This one, what happened here? Oh, this toolpath is using the back because we have locked plane here, so we're going to use here back. I forgot that this has to be on this plane. Okay, so that's okay. Result. Okay, thank you guys for watching. I hope you found it interesting and helpful, and if you have any trouble, problems with this, just put in a comment. And this is a good part for practicing, so I'm going to put it today as available for you to download and to practice and try different things, different toolpaths, and I'll leave these pockets for you to figure out how to use it with the 2D operation. And this whole part can be finished without multi-axis even. I mean, axis substitution is kind of multi-axis, but yeah. Okay, thank you guys for watching, and see you in the next tutorial. And of course, if you haven't, just don't forget to subscribe to my channel and hit this notification bell, and in this way you won't miss anything that I'm going to upload for you guys to practice. Take care, and don't forget to download this 3D model.